F1 sine 60 and that times of k. So that's the what we call as the Cartesian vector representation of the force F1. Now we need to do the same thing for force F2. So in case of force F2, it's a lot simpler because what you have here is three angles. You have the angle between force and x-axis, then you have angle between force and y-axis, you have angle between force and the z-axis. So you know three angles which are direction angles. So you have F2, a known magnitude, cosine alpha, which is really cosine of, in this particular case is 135, times of I, plus we have F2 cosine beta, which in this case is cosine 60 times the j, and then you have the F2 cosine gamma, which again in this case happen to be cosine 60 times of k. So your second force is really the same thing as case 1. When we went through in chapter 2, that thing was similar to the case 2. Okay, now we need the third force. What we know about that is, we know the starting point, which happened to be 0, 0, then if you find coordinate of that point, which is along the same as force. Now coordinate of this point, if I call this point as A, you have 4 for x, then you have 4 for y, and you have -2 for z. So your third force is same thing as case 3, but you know 2 points. You know the point O as triple zeros, you know point A as 4, 4 and -2. You know 2 points on the force. So if I want to write F3, this is going to be the unknown magnitude times a unit vector which goes from point O to A, and that's going to be F3 OA divided by its magnitude. So we really need the position vector OA. So we get OA from here, take coordinates of this, subtract from this, so there's not much you can do there. You get 4i, 4j and -2k. Then its length will be the square root of 4 square plus minus 2 square. So we got 32 minus 4. That's 36, so that would be 6. So your third force, which is F3 divided by 6, then we have 4i, 4j and -2k. Or I could write that as, let's say, F3 4, 6 I, F3 4, 6 j and F3 -2, 6 k. So we have every force now. We have one force right here, then we have the force here, let's call this as 2, then we have third force here, and we have the fourth force here. When you have all those 4 forces, you could go back to the equation here. and you add it. Now if you put all four together, it's going to be a really long equation. So what you do is you go back and look at components. So if I look at the components, we get 9 from the first equation, we get f1 cosine 60 cosine 30 from the second, then you get f2 cosine 135 from the third, then you get f3 46, and this should go to 0. Then you sum the force in the y, or look at all the y components. So now we have negative 8, then you have negative f1 cosine 60 cosine 30, then we have f2 cosine 60, then you have f3 46, and that should also add up to 0. Then we got third equation. Now we gotta look at the z components. So you get negative 5 from the first. Second one is going to give you f1 sine 60. Third one is going to give you ft cosine 60. Then you have f3 26 with a negative, and that goes to 0. So you have three equations, you have three unknowns. You solve for the f1, and that should come out to be 8.26 kilonewton. You solve for f2, that will be 3.84 kilonewton. Then you solve for f3, that's going to be 12.2 kilonewton. Okay, here should be 2106.